Last lesson of the unit. We're talking about composition of functions. Those of you that had me last year for geometry, those of you that didn't, it's okay. We talked about composition of transformations, right? Which one went first? We're doing the same thing here, but now we're going to do them algebraically. I want you to notice something. I want you to notice that these two things are the same thing, right? Because composition of functions is the process of applying one function to the results of another function. So really what we are doing is we are, because we've seen this, right? F of x, yes? Where x is our placeholder variable for input, right? So really what we're doing is in the f function, every time we see an input or the x, we're going to substitute it with our equation g of x. And we're going to have practice with that, but that's the essence of what we are talking about. Okay? And no matter what you're given, if you're given this or you're given this, they mean the same thing. So f onto g of x, f of g of x. These all mean the exact same thing. So if you're written like this, it's the exact same. What if I were to give you an equation that looked like this? G onto f of x. If I wanted to write it in this notation, what would it look like then? G of f of x. Means the same thing. Good work. And we talked about inverses before, but today we're going to algebraically determine if two equations are inverses of each other using composition of functions. And this is how we can tell. If I put g of x into my f function, or if I put f of x into my g function, it shouldn't matter. Both of them should equal x, and only x. If that occurs, they are inverses of each other. But both have to be true. They both have to equal x in order for them to be called inverses. Okay? Can I answer any questions, anybody? Okay, let's get our feet wet a little bit. If I were to ask you to evaluate this, right? You are asked, given the definitions of f of x and g of x below, find the value of f of g of 8. So our answer should be an actual numerical value for this one, okay? There are two ways you could approach this. Using the actual composition of functions or evaluating first. Let's do the evaluating first. I want to figure out what g of 8 is because we've done this. We have the knowledge to do this very quickly. G of 8 should equal 2. Can I answer any questions here? Are we okay? No, why are we not okay? Yep. Instead of x, I want to evaluate for 8. So that means that 8 minus 6 will equal 2. Right? We already have the necessary knowledge for this. We should automatically be in those gears. Okay, now that I have this turns into f of 2, which now you can evaluate, right? F of 2 is going to equal 3 times the quantity of 2 squared plus 2 plus 12. This turns into 3 times 4 plus 2 plus 12. And all of this evaluates to 26. Yes?
So the f of 2, instead of you doing the f of x with 8, you would put 2?
Right, so I do g of 8 first. I evaluate that and get the answer for that. And we said together it was 2. That's why I circled it, because it's important, but it's not my final answer. And then from there, because I evaluated what g of 8 was, all of that turned into the number 2. And then I evaluate my f function with the number 2. Are we okay, everybody? Can I answer any questions about the first example? I want to give you 3 minutes for this. Try example 2. I would love a volunteer to come up and actually walk us through the problem also. So be prepared to share. Go. Would anybody like to volunteer and walk us through the problem? Nobody? You should go walk us through the problem. I do. The pen is right next to the iPad.
Okay.
Talk to us. Walk us through all the math, all the process.
So,
In the composition of functions, it told us that f times g times 4 was equal to f g 4. So I used that to put this into this one. So it became g4 equals 4 squared minus 4 minus 5. That's 16. And so now we know that g equals 7. So here we put f7, and then we're going to put the 7 into the other equation. So, okay. So now we have f7 equals negative 3 times 7 minus 14. Negative 3 times 7 is negative 21. And then minus 14 is negative 35. So the value f is negative 35.
You got that right, everybody. That's absolutely correct. The answer is negative 35 indeed. So let's walk through the process very quickly. G of 4. One thing I will caution you to do and not get lazy on is doing it with parentheses. And the only reason I tell you is because when you get negative numbers, if you put this into for example, if it had been negative 4, some of you would have just done this. And in the calculator, you are not going to get the correct value. Because what this is really doing in the calculator is doing this. It's squaring the 4 first, and then multiplying it by negative 1, which would have given you negative 16 rather than the true value 16. That is my only caution to you, because the rest of this math is spot on. Yes, this turns into 16 minus 4 minus 5. 16 minus 9 is 7. Good, I'm going to plug this value into my f function, and I indeed get negative 35. That's it. How do we feel, everybody? Good. Okay. I want you to just do, I don't have enough time to do example 3. Let's just do example 4. Given the definitions of f of x and g of x below, find the value of g onto f of negative 2. I'm going to give you another 3 minutes, and then I'm going to select a volunteer based on your work. So 3 minutes. So I will volunteer you to go up there. Go. everybody, here we go. I have voluntold a student to come up here. Apparently, student examples work better than the last class. So we'll take a look. All right, you want to talk to us, walk us through the whole thing.
So it's g of f. So g of f is negative 2. So since f of negative 2, you can substitute it for f of negative 2 equals negative 4 times negative 2 minus 9. And negative 4 times negative 2 is 8 and minus 9. And 8 minus 9 is negative 1. So f equals negative 1. And then g to negative 1. Well, how do I erase it?
There's an eraser up on the top on the iPad. Yeah, just click on it and then erase it.
Okay. And then, so, since f is negative 1, you can do g to negative 1 equals 3 times negative 1 squared. Can I erase it so I have more
Of course
room?
you can.
Squared minus 6 times negative 1 minus 12. So you do negative 1 squared, which is 1, and then 3 times 1 is just 3. So negative 6 times negative 1 is 6. So minus 12. And 3 plus 6 is 9. Minus 12. So the answer was negative 3.
Give you a round of applause, everybody. That is absolutely correct. Absolutely correct. Can I answer any questions here? I feel like there potentially might be a disconnect here, everybody. This is the same mathematical thing as adding negative 6 times negative 1. Right? Subtracting a number is the same thing as adding a negative number, right? It's the same type of logic. So keep in mind when you do these things, this is going back all the way to 6th grade math. Same thing. Okay? That's where we were able to get the positive 6 from. Cool. How do we feel, everybody? Good? Okay. So now you've been able to get some type of output. We're going to do that. However, we are not going to actually get an output that's of value. We're going to get an output as a whole new equation. Right? But the concept is the same, right? What are we doing here? We are going to put g of x wherever we see an x in the f function. Right? So remember, this is my input into this equation, whatever this is, right? In this case, we're told to put g of x, so all of this, into the inputs of this function. So where is my input here? Right? Well, there's only one input, this x. So here's what I'm going to do. F of g of x is going to equal, in parentheses, 3x squared minus 6x minus 10 minus 14. Now, everybody, delta math is very unforgiving here. This is not enough. This is absolutely not enough. We need to simplify this. Well, there's nothing being multiplied to it. There is no power here, and there's no division underneath. So we can now open up the parentheses, which will give me that f of g of x is equal to 3x squared minus 6x minus 24. Yes.
So for like the fx one at the top,
Mm-hmm.
that one can we put f gx, so you'll put the f gx in the gx. Like
Is it always going to be like that, are you asking?
yeah,
Like f of g of x?
yes.
No. They could tell you something like that. G of f of x. Is that your question?
But no, I'm asking like, can the f of g of x go into either fx or gx function or?
You are specifically told to evaluate it for this. So we need to follow this. So g of x needs to go into f of x in this particular case. Does that answer your question?
Yes.
Are you sure? Okay, so then how can I help?
Like, I don't understand like, why did you only put, I guess, why did you only put it in the gx function? Are we gonna do the fx function?
No, I did. Here, let me.
Oh. So it just goes into both of them?
This was the placeholder for x. And this part also went into the equation.
Okay, I see.
But instead of x, we've been told to put in a new input. In this case, my input is g of x. So my input, instead of x, every time I see an input variable placeholder, I'm going to substitute it with whatever g of x is, which is the function. That is how we do composition functions. Now did I answer your question?
Yes.
Cool. So technically we did write the equation x minus 14, but instead of x, we are told to put in g of x. Can I answer any questions? All right, well, if you think you got it, then I'll give you 4 minutes for this one. This one, everybody, needs to be simplified the entire way. I'm gonna give you 6 minutes for this. This needs to be simplified completely.
So like, no.
Everything. It needs to be in standard form. It needs to be. So, go. This one. Do all the work, watch. Trust me. Do all the work for it. You'll find it. Well, remember, this F of G is the same thing as this. So you need to put in whatever G is GF. No, it doesn't, well, I don't know what you mean by change it. Yeah. No, when you put it in, you substitute everything in parentheses either way. You bring in the negative sign as well. It's because which one is going into which one? Tell me. Which equation is going into which equation? Yes, that's why. That's where my disconnect comes. Oh, it would be 2 times negative x plus 5 squared. Yeah. Yes, your first step is absolutely right. On my way. What's up? Okay, you're starting off with f. Okay, so now every time you see an x, instead of putting x, you substitute what? You just need the other part, right? Which is negative x plus 5. Yep. So now you rewrite it as negative x. Exactly. Yep. Is there another x? Yep. Exactly right. So you have the first step down. Everybody have about 2.5 minutes. Try on your own first, and then we'll.
I have. It's not. What do you want the negative x?
You have to bring it in.
Well, see, do we put this directly into the x?
Yes, literally that's.
So literally that's all we're doing.
Yeah.
It's
But then you gotta simplify it.
Well,
Yep.
I was getting this and
Yeah.
something else was happening.
Right, but this is obviously like the meat.
I
It's the
did-
bones of the.
I finished
the
this one.
were you all able to get everything situated?
Yeah, our dishwasher is currently like in the middle of the kitchen.
Oh yeah,
It's,
that
like,
happens.
sitting there.
But at least the plumbing.
But at least the water's turned on, so
That's a good thing.
we're good.
Oh, you're putting in the wrong one. Every time you see an x in this equation, you're going to put in that. Yes. Yes. No, I don't see it. I don't see it. Yes, but
This one is fine.
you missed the whole step here.
He said,
That is x negative x squared plus 5. That there it goes. That's the only part that you're missing. Anyhow, Alright everybody, I'm just gonna take the liberty here. Let me first start by revealing what the answer is. The answer for this is 2x squared minus 25x plus 90. That is what f of g of x, or better said, the composition of g to f of x is equal to that. I'm going to walk through it. Are we ready?
yes.
The first step you should be able to handle. You should know which one is going into where. Here's a quick trick that I like to remember. If I see this notation, I know to start off with the right function. So whichever one the furthest right, in this case is g. G is going into f. Okay. So then every time I see, so this is f of, no, let's start writing it in that notation. F composition of g of x is equal to, hold up, 2 times whatever the g function is, negative x plus 5 squared, plus 5 times x, but instead I'm going to write negative x plus 5 plus 15. Are we okay so far? Can I answer any questions as to how I was able to ascertain this step? This is important. If you don't have the right setup, all your algebra is pointless at this point. No questions. We're okay. All right. This is the part that concerns me a little bit, y'all. You see this and you're like, oh, this is just going to square these two things. No. That is not the right way to do that. Here's how to properly do that. What are we saying here? If I were to write it as a multiplication, that means that negative x plus 5 needs to what? Be multiplied by itself, right? Negative x plus 5. The majority of you, well, all of you took Algebra 1 at some point before getting here. There were 3 ways you were introduced to do this. FOIL, distribution, or the box method. I highly recommend you use the box method. The box method is what I like to call our Punnett square. I think it's 2 T's square. Right? For those of you that are either taking biology or taking biology, right? You have one parent has a recessive gene. The other parent has dominant genes. And then each square is the multiplication of these genes. It's the same thing with algebra. It's the same thing with equations, right? So here's how we do it using the box method. I say negative x plus 5 times negative x plus 5. Negative x times negative x gives me what? Well, a negative times a negative is a positive, okay? And then x times x, since it's the same base, what are we going to do with the exponents? We're going to what? Right, we're squaring them, but that means multiplying them. When we multiply terms with the same base, what do we do with the exponents? No, we add them. This is simple Algebra 1, everybody. We're literally kicking back to Algebra 1. Okay, 5 times negative x, that's negative 5x. Same thing here. Negative x times 5 is negative 5x. And then 5 times 5 is 25. Okay, I have this x squared. I have this negative 5x. I also have this negative 5x. And then I have this 25. Are there any terms that I can combine? Are there any like terms? Yes. These two. Negative 5x's minus another 5x's will give me what? Negative 10x's. This, everybody, is how to properly square a binomial. Cool. Now let's take it back. So, let me move this down. So now this turns into 2 times x squared minus 10x plus 25 plus 5 times negative x plus 5 plus 15. Now you can do this. Let's distribute. This is 2x squared minus 20x plus 50 minus 5x plus 25 plus 15. So here's how I like to do this, everybody. I like to see if there's any like terms. Are there any x squareds besides that one? No. So this will equal 2x squared. I'm just going to cross it off because I know I'm done with it. Are there any terms with an x to the 1 power? Yes, there's that one and this one. So this turns into negative 25x. So they're done. Now, are there any constants besides this one? Yes, the 50, the 25, and the 15. Adding them all up together gives me positive 90. And there, everybody, is how I compose both of those functions. Can I answer any questions? How did that 5 turn negative? Great question. 5 times negative 1x gives me negative 5x. Can I answer any other questions? Please feel comfortable to ask questions. I'm here to help. Okay. I want you to try this problem. Using the same steps that we just did to conquer this problem, can you now handle a problem that looks like this? I'm going to give you 6 minutes now. Again, work on it. See what you come up with. Go. Write it down so that I can go up and give you all my work for the other problem. Are we okay? Oh, y'all have your computers here. Here's all my work. Here's all my work for that problem. Example 4. Wait. No, do example 4. We're doing example 4, everybody. Example 4. work on it on your own. Talk about it with your group. You can. Why not? Negative 6 times positive 11. Close. Plug in. Negative 6 times 11. Yeah. Negative 6 times 11. You were at this spot here. Minus 6x plus 11. This should be negative 6 minus 66. Plus. I think it was like 121 and then yeah. 66 and then plus 2 I think were the constants of it. Oh, yeah. I got it. Okay, what's that? Alright, ready to go. The answer. Drum roll. Here we go. G onto f of x is equal to x squared plus 16x plus 57. Right? Obviously, everybody, the struggle today was how to multiply binomials. That is Algebra 1 content. I had an accusation that we never did this in Algebra 1 by a junior in my last class, and I have receipts. I have 2 years worth of receipts that we've done this before. At least for those that had me. But I know with certainty that even though you didn't have me, we talked about the box method, specifically last year. Because that's the only one we showed. We showed FOIL distribution, but last year we only showed how to do the box method. That's it. So you all should have had knowledge there. But real quickly, for those of you that didn't get to the answer and you do want to see an explanation real quick, I'm going to fast track it. G onto f of x is equal to x plus 11 squared minus 6 times the quantity of x plus 11 plus 2. This, everybody, turns into x squared plus 22x plus 121. This, everybody, after I distribute it, turns into minus 6x minus 66 plus 2. There are no other x squared, so that one goes. There are 2 of these here, so this turns into plus 16x. Gone. This minus this plus this turns into positive 57. So g of x is equal to that. How do we feel, everybody? Good. Okay. There will be instances where 2 functions might not be the only thing that you're given. You might be given 3. Believe it or not, this is a bit easier than what we just did. So let's take a look. Which one goes first according to this composition of functions? Which one goes first? It's not C. It's not C. F. You start with the right furthest. Right furthest. And then go this direction. So here first, then all the way towards the left. Okay. So we start with F. So F is going to go into what function? Z. Okay, so then I rewrite this as square root of e to the x. And then all of that is going to go into what? C. So then my answer to this is 8 divided by the square root of e to the x minus 2. Yes. No. That cannot be simplified. However, you might have to simplify it on an exam. This was not, you can't simplify it further, but there may be a situation where on an exam it will be simplified and you will be instructed to simplify it. So although this one cannot be simplified further, if I were to give you a function, let's say, f of x is equal to x squared plus 2x plus 1. G of x is equal to x plus 2. And then h of x is equal to 7. Or, nah, too easy. Let's do negative x plus 1. This can be simplified if I were to ask you to do that. And I just made that up on the spot. It could have been anything. Questions, anybody? Right now we're focused on this. This is what I want you focused on. S of W of B of X gives me what? Okay, which one am I starting off with? B, okay, so this is my first. It's going into which function? W, so over here. So every time I see the X, I'm substituting it with this. So far I have 3 to the square root of X. And then this is going to go into what? S. So my answer for this is 4 divided by 3 to the square root of x plus 6. Questions, anybody? Let's see. I think we got the hang of it, right? Yes? You'll have a couple problems on delta to work on that. Here's what I want to talk about. Let's go back to inverse functions for a moment, right? We said, going back to this, that an inverse function has to be reflected over y is equal to x for this to work. Well, using what we just know, and going back to the vocab, if they are inverses of each other algebraically, the composition of f of g of x must equal the composition of g of f of x, and all of that should equal x. Now, what does this mean? This means that if this, after I do this, what the result is x, and if I do this, the result is x, then that means they are inverses of each other. And that will probably be on an exam. So let's do some practice. Using composition of functions to use composition of functions to determine whether the functions f of x is equal to 1/2 x minus 3 and g of x is equal to 2x plus 6 are inverses of each other. Okay, well, what did we say? F of g of x first, and then g of f of x. Okay, let's do it. 1/2 times the quantity of 2x plus 6 minus 3. And for this one, it's going to be 2 times the quantity of 1/2 x minus 3 plus 6. I want to give you about 3 minutes for this. Evaluate these. What do you get? So 3 minutes on the clock. Go. The question I want you to answer is, are these inverses of each other? Yes or no? Short answer for this, are they inverses of each other? Long answer requires algebra. Let's do it real quick. Just going to distribute this and this. So 1/2 times 2x gives me x. 1/2 times 6 gives me positive 3. minus 3. This equals x. Okay, so far we are good. Everybody, it is important. You can't just evaluate for one, because there might be some scenarios where this might be just x, but this isn't. Both of them have to equal x in order for them to be considered inverses of each other. So let's do it here. Distribute, distribute. We get 2 times 1/2. That gives me 1, so x. 2 times -3 gives me -6 plus 6. This gives me x. So yes, they're inverses of each other because they both equal x. Good. Okay, last example for the day. Example number 2. Are these inverses of each other, yes or no? I'm going to give you 2 minutes for this one. Go. 2. Example 2. Alright, everybody, here we go. Short answer, yes or no? No. Why? Let's take a look. Let me use the other notation. This is going to be 3 times 1/3 x plus 2 minus 2. So it turns into x plus 6 minus 2. This is x plus 4. Everybody at this point, I personally would just stop. Because what's the goal here? We just need x. But we got x plus 4. We can't do that. They both have to equal x at the end of the composition. Right? So I would just stop. But for the clout for the video, I am going to just do the other part real quick. So 1/3, 3, x minus 2, plus 2. This turns into x minus 2/3, plus 2. Even if I were to add these two, even if I were to combine these two like terms, I still wouldn't get x by itself. So, no is the answer. Yes, Eva. that doesn't matter. If we're asking if they are inverses of each other, it wouldn't matter. It has to be equal to x. That's how we know they're inverses of each other. So cool if they end up equaling the same thing once I compose them together. But if they do not equal x, they are not inverses of each other. Does that answer your question? Fantastic. Can I answer any other questions? Beautiful, everybody. You have about 20-something minutes to work on your Delta Math assignment. So let's get to it.